We've been increasing fertilizer consumption and use drastically over the last 30 years, but mostly over the last 80 years since it really came into common use. And it's taken its toll on soils. Wherever there's intense agricultural production, you're finding lower soil carbon, lower organic matter. Basically, we're getting down to dirt. And it's no longer a living soil, it's dirt. You've had a whole slew of lawsuits already of farmers suing municipalities because their land is no longer able to be farmed. The problem is nationwide. Today we're doing a trial test on basically a pyrolysis kiln where we're taking dried products and we're running it through the kiln to make carbon. The products we're taking in are dried biosolids from the North Shore Water Reclamation District in Chicago, and we're processing 150 tons of that material along with 20 tons of wood waste.
This demonstration should make it clear how simple it can be to use this type of technology to remediate biosolids. We can get the PFAS out, we can turn this material into something very clean, dry, and useful that permanently sequesters carbon, and this is way cheaper than any of the technologies you're looking at today. What you see in the diagram is a very simplistic flow of our full-scale facility. You see wet biosolids entering a feedstock drying component. That's a rotary drum dryer, and the dried biosolids exit that, and then they enter the pyrolysis kiln. That's what you're seeing here in the field trial today. The gases from the pyrolysis kiln then enter a thermal oxidation system, which fires all that synthesis gas, extracts all the energy from it into the form of heat, which is then used to actually dry the inbound material. The thermal oxidation enables us to break down and totally mineralize all volatile organic compounds, especially PFAS. The air then exiting the dryer goes through the air and odor treatment system. And then we have some of that air and water actually going back into the thermal oxidation system. It's used for cooling. Out of all that comes the carbon fertilizer. So that's actually the product.
We're getting down to something fully remediated, has no chemical contaminants in it. The sewer retains the soil organic matter. You'd never be able to accomplish this with incineration. These facilities today are chugging out a lot of PFAS or other carbon dioxide equivalent emissions into the atmosphere. Our process is actually carbon negative, so it's a major reduction in greenhouse gas emissions. That's really the purpose of this, is to take a waste, take all the bad stuff out, and rapidly build soil carbon and organic matter back up again. It has excellent properties for seeding crops, establishing roots early, getting higher yields out of products with less nutrient inputs. We've developed an advanced thermal oxidation system so that we can put this on the back end of wastewater treatment plants. And so we have a distributed network of facilities producing this carbon fertilizer. It all kind of works in tandem to just make agriculture and waste management more sustainable, quite frankly.